This is yours, it's mine. Good morning, everyone. Could you hear me? Okay. Thanks a lot for the invitation. I am so glad to be here today. It's a great opportunity for me to meet again new friends and old friends and to have an opportunity to learn more about these important issues with you. So, the topic that I propose for my talk is a so pretentious topic. So I don't want to do a, okay.
As we know,
I don't want to, and I am not able to do a review about this topic. Okay? I just point out some things that I consider could be interesting to think more. And then I decided to start to show us an obvious scenario. Our species are dependent of water. There isn't any species that is able to complete their biological cycle. This is completely independent, yeah? Okay. There isn't any species that is able to complete their life cycle without water. Thinking about that make it easier to understand the completely relationship between sustainable environmental development and human health. And aquatic ecosystem is a good example to integrate this internal dependence about environment and human health. But what happened today? Our species are growing going so fast. We have more than 7 billion human beings. And why we are so many? Well, in the last 2 centuries, we observe an exponential growth of our species because we are able to offer more food for people. Then we have an agriculture revolution behind it. We have an industrial revolution that gives us more comfortable life and allow us to have a urban society. And we have improvement in sanitation and medicines. It's a good thing. It's a good thing. But this set of development or progress make a strong pressure over the water research, mainly in developing countries where the economic development is not linked with social and sanitation process and environmental protection. So it's so common in different places you see scenarios like this. Unfortunately, it's so common nowadays around big cities you see scenarios like this. And we are taking, when we are taking account a recent from last year report from WHO, we see that around 70% of global population are receiving a safety managed drinking water service. But on average, this distribution presents a strong variation. And in developing countries, the average is lower than 40% sometimes. When we take in account sanitation service, this average goes down. Around 39% of global population receive a safety sanitation service. But when we look for developing region, this number is so smaller. So this scenario plus extreme weather events, that's our reality nowadays, or we have a strong drought season or strong floods, it makes a big impact in our environmental aquatic ecosystems. So the combination of this anthropogenic impact plus climate change is promoting the increase of cyanobacteria bloom. This complex dynamic and interference that we don't know yet how complex it could be is promoted an increase of the occurrence of cyanobacteria blooms. However, what cyanobacteria means? What is cyanobacteria? This is a huge and diverse group of photosynthetic prokaryote microorganisms that present a big difference in shape and size of cells, ecological strategies, secondary metabolites that they are able to produce. So there is no rule for cyanobacteria. It's a completely diverse and dynamic group. So when you look photos like this, we realize that anyone of here can have better photos than this. This is a common phenomena anywhere nowadays. This photo is from Brazil, but you have photos from Australia, from Africa, anyone has their own photos about cyanobacteria blooms. But the records about the occurrence of cyanobacteria blooms show us that's not a new issue. It's an old issue. When you look for some data in Europe, we can realize that at least 1,000 years ago, there is some records about cyanobacteria occurrence, or looks like cyanobacteria bloom. And there are also reports indicating by traditional knowledge that this phenomena was known in primitive people from North America, Africa, even in Australia. But take longer to have the first technical report about animal death by injection of cyanobacteria. The most famous one was doing here in Australia, the Francis paper published in Nature in 1878, but other at the same decade was published in Europe. So in the end of the 19th century, people stay aware and do some technical reports about a relation, animal death and cyanobacterial bloom occurrence. It's important because people be aware, because they are lost some animal that represent economic force for them. So people say, okay, this is an economic trouble for us. And then in the beginning of 20th century, we can find some first paper, a pioneer paper confirming the toxic effects in domestic animal, published in a veterinary journal in Canada, or other reports in Argentina, South Africa, Canada, and some papers reporting allergic reaction for people with exposure to cyanobacteria, and a pioneer works starting using bioassays. Let's make a turning point in this area, because at the same time that people start to be interested in toxicology of cyanobacteria, we could not observe the same interest in ecology or ecophysiology of cyanobacteria. People that work with limnology or ecology of phytoplankton is still decreasing other species, occurrence of other genera, and doing the classical ecological study, including cyanobacteria as a group of microalgae in phytoplankton. So the relationship between ecology studies and toxicology studies was disrupted. In my opinion, it's not a good thing that time, because the toxicologist, is faster than me, yeah? I don't like this machine that has the control, okay? The toxicology studies start to focus on the mechanism of action of toxins, but these people that's doing that doesn't know nothing about the ecology of cyanobacteria and don't care about it. The people that stay doing phytoplankton ecology, they don't know nothing about toxicology and don't care about it. So it's make a big division in this field, and people not stay aware for a long time about the other side of this problem. So In the beginning of 90s decade, we have already a good number of studies about cyanotoxins, okay, made by chemistry, biochemistry, toxicology. And according of the mechanism of action, this molecule was divided in two different groups. One group set the neurotoxin that has the main target, the neurosystem, and the other group was classified as a hepatotoxins that time because the main target was the liver, okay? And more than this, we can find a pioneer register about gastrointestinal and the hepatic illness reporting by cyanotoxins in drink water supply. There is one old description in 1931 in Ohio, and then 79, the classical study in Palm Island disease, okay, where after that we could detect cylindrospermopsin. Cylindrospermopsin could be described. And 81, again in Australia, Armendali. And then 88, this case was not well known since a few years ago in Brazil when they opened a new reservoir in Bahia state. The government that time prohibited to announce this case in the media. Okay, so even in Brazil, we don't know about this case for many years. And in 94, also in Europe, we have some cases of illness in gastrointestinal problems due to microcystis in drink water. Well, this is the scenario when in 1996, happening a severe incidence in Northeast area in Brazil, Pernambuco state. We are starting our toxicology study with animals. I used mice bioassays that time. When we start to hear about that in a clinic, hemodialysis clinic in Caruaru town, more than 100 patients start to present some intoxication troubles after the hemodialysis treatment. And the symptoms was so related with liver failure. After 1 week after the initial symptoms, we registered the first death, and then people stay aware what happened. Nobody, no medical doctor could explain what happened with that people that time. But let me try to explain to you what happened. In this region in Brazil, until now, this region is under some severe drought seasons, many years sometimes. That last drought season stay for 6 years without rain. So in this region, it's so common to find Cyanobacteria bloom in the reservoir. And that time there was one reservoir that supply water for Caruaru city. It's a 40 kilometers of distance. The water treatment system in the town was so simple. And during the drought season, a dialysis center that was in a hill needs to receive water by a tank delivery. Okay? The water could not have pressure to go up, and then they take a truck to take water for this center. This is official story, okay? But after the water comes through the dialysis clinic, they have an in-house water treatment system. That means sand filtration, carbon filtration, ion exchange, resins filtration, and then micropore filter to go to dialysis room, okay? That time, the reverse osmosis was not obliged in Brazil. And in many other places that time, they do only this kind of water treatment. But there are some key points that need to be considered. For example, the truck driver received an orientation that if the water was so turbidity, visual turbidity, he needs to put some chlorine in the water. And we could prove that they never use only treated water. They also take raw water because they consider that in-house water treatment would be enough, okay? Because they are paying for the water. And also the dialysis filter that time, we could see that they are overused. Well, unfortunately, the phytoplankton counting during the outbreak period was not done. So I was in that reservoir in March, a month later of the start of the outbreak, but we could confirm that cyanobacteria was more than 99% of the dominance of phytoplankton samples. And we could also analyze microcystin in cylindrospermopsins, in carbon and ion exchange resin and sand filtration, doing methanol extraction, only water extraction. We could demonstrate that the filter was completely saturated, and then we could extract microcystin and also cylindrospermopsin from the filters and from some resins. That means, okay, the carbon is working, but when we test with a standard of, we spike some standard of microcystin, and through the water, we pass water in the filter, the microcystin appear plus something. Then the carbon is not retain anything that time. So, all victims present positive results for microcystin in serum and in liver tissue that we could analyze. All victims present this, and the histopathological analysis was completely similar that one we observed for animal experimental tests. Then the histopathological profile is so similar with acute intoxication done by microcystin. And also chemical analysis from some liver sample could allow us to identify at least 3 different microcystin. Microcystin LR, microcystin RR, and microcystin YR. Well, if we can say that there was some positive result after this incident, is because is the first confirmed outbreak by human intoxication done by cyanotoxins. It put people more aware about the potential risk for human beings, okay? But I don't believe that it only happened there. It's because we have opportunity to study. We have open minds to allow us to take samples and to study. Okay? Because situation like we observe in Caruaru, we can observe in any developing country. But sometimes by a political decision or something like that, not allow the research to do a good survey about this. And also Professor Komariki helped us so much, and we could describe new species from these phytoplankton samples, and put out one important issue, and until now I believe we are underestimate the participation with about phytoplanktonic species of cyanobacteria when we estimate the biomass of cyanobacteria. And we have serious troubles nowadays in big cities, in São Paulo City, Rio de Janeiro City, when we consider the number of cells of phytoplanktonic. And some people think, okay, but they are so small. The biovolume is completely different if a colony of microcystin. But when you consider that we are talking about genes that produce a molecule, doesn't matter the biovolume, matter the number of DNA that we have, okay? So we are until now underestimate the participation of the phytoplanktonic species in these events. Well, in 1999, WHO published the first guideline about toxic cyanobacteria in water, And from 2000, the health ministry in Brazil decided to include cyanobacteria and cyanotoxins as a mandatory parameter to regulate the quality of water, drinking water, for distribution of drinking water. Nowadays, our TDI values are for microcystin, 1 microgram per liter, saxitoxins, 3 microgram per liter, and cylindrospermopsin, 1 microgram. I don't know why I saw in some recent reviews they are putting 15 micrograms in Brazil. No, it's 1 microgram. But the difference is for microcystin in saxitoxin is a mandatory parameter, okay? Because we have a lot of cylindrospermopsis producing saxitoxins in Brazil. And cylindrospermopsins is a recommendation. This is the difference, but the value is 1 micrograms, not 15 micrograms, okay? Well, back to the environment. When you look for the complex trophic connection among organisms and cyanotoxins, and I am using a cartoon, a very good cartoon that Professor Hansberg gave me gently, so we can realize how complex this relation could be between our aquatic organisms and human beings. It's a complex relation that depends for many factors to be understandable. But talking about the human exposure of cyanotoxins, we know that we have different routes of exposure. The most common and considerable route is the oral exposure because people is much more aware about drink water quality and the potential contamination drink water quality, okay? But also we need to pay attention in food exposure too, because the bioaccumulation of aquatic animals is possible, and the aquaculture industry is increasing so much in many countries. So when you put aquaculture in some reservoir, it's so common nowadays in Brazil, we promote a strong eutrophication process. So it starts to be common to have cyanobacteria blooms around these cages. And we are not consider the potential bioaccumulation in the food comes from this aquaculture service. Also, recreational activities sometimes is underestimated, but if you consider the age of people that could be exposure in these recreational activities and the time and frequency that these people use some beaches or some lakes, we need to think more about this exposure route. Of course, inhalation needs to be in account too. If you consider that for some cyanotoxins, the toxicity could be 10 or 100 times higher when you consider inhalation view than oral exposure by drink water. This needs to be considered also. The spray of, we have done some studies about the spray that you close the beach, but people stay in the sands. And you have the spray, and if you consider that your lung represents a 4 square meter of contact with the external environment, then the exposure by inhalation needs also to be considered, both for recreational activities and more for professional activities. Some people work in the fields, and they stay using this system all day long. A special group of people could be also contaminated by intravenous routes. Again, the renal dialysis patients that needs water 3 times per week to be alive. And I don't know if you know, but each hemodialysis section, we use 120 liters of water during 4 hours. So it's completely different to drink 2 liters of water per oral consumption. And only a thick filter separates your blood from this water. So any problem in water quality is much more dangerous for this kind of people. Even for people that stay hospitalized for a long time using parenteral support. I don't know here, I would like to know, but until now in Brazil, there is no special regulation for water quality that is used to prepare this syrup. For example, you are receiving glucose or something. How many liters you can receive during long periods? Who is controlling the quality of this water? Consider the potential presence of cyanotoxins in this syrup. They look for other compounds, not for cyanotoxins. Well, usually the records about gastrointestinal and hepatic illness are coincident with natural background of cyanobacterial bloom when we are talking about oral injection, or artificial background doing by use of some chemical to kill the bloom. So the cyanotoxins are released in the water, and if the water treatment is not effective to remove the dissolved cyanotoxins, then you have exposition, okay? Also, the bioaccumulation, we have done for many years this study in a coastal lagoon in Rio de Janeiro city, and we could also demonstrate the transference of microcystin by cystone and visceral organs and muscle in tilapia that reach 18 times higher than the TDA values for estimate intake. So imagine a child that, from a fisherman that gets this fish every day, okay? And after that, a paper that more than 10 years ago now summarized in a table other reports about the microcystin in aquatic organisms. It's not new. Also recreational activities. This is pioneer works done about recreational activities in short-term effects in human. In Australia, you are doing the best study about this, in my opinion. Intravenous route. There is one case in 1975 in the US, but it's an endotoxin shock because cyanobacteria is also able to produce some, it's a gram-positive bacteria, gram-negative bacteria, so that we can have this, but nobody could prove that cyanotoxins are also involved. Of course, Brazil, and in 2001 we have another incident in Rio de Janeiro, but at that time the level of microcystin is in the legislation control is less than 1 microgram per liter, but when you consider dialysis patients, it could be so much. Nobody died at this, but allow us to study the dynamic of depuration of microcystin in the dialysis patient for 3 months. Liver cancer have been much more studied in China. Some epidemiological studies prove that there is some relationship with hepatocellular carcinoma. Other epidemiological studies could not prove yet, but in China they are doing the best work about it. Food also, the bioaccumulation in different aquatic organisms. Dietary supplements also could have some participation of the transference of cyanobacteria through the food web. But a recent review show us this interesting map. They only put 1 point in each country, okay? Doesn't matter the number of occurrence. But as we can see nowadays, we have occurrence registered in any country. Almost few of them doesn't have any occurrence register yet, okay? But when you look for the health effects reports related with cyanotoxins, it's surprising. Only few countries have already do some correlation between reports of health effects and cyanotoxins occurrence. In my opinion, that it means people is not doing the research there. I don't believe that there is no effect. It's We have more data where people is more aware or have a better research condition or knows more, have better collaboration. Only this map say for us. According to publication, only in 11 countries we have some studies about health effects. China, much more about cancer and chronic disease. Then we have Australia, Brazil, Serbia, and so on. So only in 11 countries we have already some publications about health outcome related with cyanobacteria. Well, when you look for what we know about ecology and the ecophysiology of cyanobacteria, we can say, okay, we know the main dominant species in different places, but we know who is the dominant species. We know the main environmental, that means physical, chemical, and biological factors that are related with the growth of cyanobacteria. This is important because when I am talking about management, it's important to know the growth of cyanobacteria. But one question is still open and needs to be focused is why cyanotoxins are produced. Why these bacteria decided to produce? First of all, we say cyanotoxins because it's able to kill mammalians. If it's not kill mammalians, we don't care about. We are thinking because our species are involved. It's only kill insects or something we don't care about, okay? Well, in the beginning and until now, some people say, okay, it's to prevent grazing, okay? I don't want to be eaten, so then I produce a secondary metabolite, and the aquatic organism cannot eat me, okay? There is a very nice studies, but it's difficult when you use, for example, zooplankton to separate distinguish among low nutrition value of cyanobacteria, physical restriction for ingestion, for example, morphology of different species, and toxin effects. We have acute effects, chronic effects, but the effects are dependent of the type of toxins, the zooplankton species, the concentration used, the time of exposure, and diversity of food supply. It's difficult to have a general rule for interpreting this data. In spite of it, a very good meta-analysis proves us that zooplankton is able to concentrate microcystin, and an important report, it's more than 10 years now, but Hantala said that why our organism will produce a toxins to kill an animal that doesn't exist when they start to produce these toxins, because the ability to produce microcystin, for example, predates the metasome lineage, okay? Maybe allelopathy, could be. A lot of studies have been done, each day we have more. However, when you analyze this data, field data used in the experimental design, real concentration that we can find in the environment. When you do toxicology study in the lab, you use lots. But to interpret it in an ecological point of view, you need to use concentration that's happening in real world, okay? And few experimental are doing using this relevant concentration. Also, other components as alkaloids, peptides, fatty acids seem to be more pronunciated in phytoplankton species than the classical cyanotoxins. Infochemical or quorum sensing, I like it. I'm trying to do something around it. But also it's difficult to say, okay, is microcystin or saxitoxins the main target molecule to produce this chemical communication? And why to explain the case of non-toxic strain of microcystin succeeded the toxic strain during cyanobacterial bloom dynamic? Well, in my opinion, our knowledge about the role of cyanotoxin is just in the beginning. We need to know much more to manage better this scenario. Summarizing, we are talking about a high diversity group with different strategies, with a high diversity of metabolites, and we are still concentrating few metabolites that they produce, okay? And we need to open our mind to consider the synergistic effect between whole metabolites that they produce. And we are changing the environment for the environment there where they appear. Cyanobacteria appeared in our planet for more than 3 billion years ago. And that time we don't have oligotrophic environment. It's a soup with a lot of organic matter, nutrients, and so on. They are so adapted for these environments. So we are changing the aquatic environment for their preference. So, of course they want, okay? In my opinion, then, to take into account cyanobacteria issues, first of all, we need to listen to each other. Nobody is able to solve this problem. It's a lesson for humility. We need to know that we need much more than one discipline or two disciplines to solve it. And we need to stay together to know that how much we don't know about it and ask help for other colleagues, for other disciplines. Only in this way we can really have a good advance in this issue. It's a good lesson to be learned for our society. And environmental and health, it's much more than a multidisciplinary academic challenge. And we cannot no longer postpone it. Thank you so much for your attention. It's a part of my team in Federal University of Rio de Janeiro. Thank you. Thank you so much.
Thank you, Sandra. That was a fantastic presentation.